Good evening, everyone. My name is Vidal Beiruti. I'm a senior solution architect with AWS. I've been with AWS for 2 years now, but before that, obviously I come from a long experience in IT, working in different verticals, banking, AdTech. I'm an expert in AdTech. Anybody working in AdTech? No? Yeah, we have one there. So it's a unique experience. And working as well in cloud technologies, working in databases, working in analytics. But my interest in machine learning comes from two sides. First thing, I have a PhD in machine learning. So what Nick was presenting about those diffusion matrix and those hidden Markov models, this is my specialty in my PhD. But I applied hidden Markov models on behavioral analytics. And behavioral analytics is important for different aspects. For example, I've used it in transaction fraud detection, behavioral analytics, for example, and use it in AdTech as well for behavioral analytics to monetize data, as well for mobile network providers. So different areas, but this is the first side of things for my interest in machine learning. The other interest is part of AWS. When I joined AWS, I wasn't using SageMaker at all. I was using other tools, and then I started learning SageMaker and started building my capability in AWS tools. And now I am a member of the technical field committee for machine learning in AWS. So this is kind of my interest in machine learning. Currently, I work with the enterprise team. So I work with enterprise customers and mid-sized enterprise customers. And I provide for all aspects. So I will speak in the morning about analytics, then I'll speak in the afternoon about warehousing, then I'll speak after that about machine learning, and then somebody will come and discuss blockchain, and I have to provide for all of that. It's not an easy job to do, but this is what a solution architect life in AWS is. Today, we're gonna discuss well-architected framework and specifically speak about machine learning lens in well-architected framework. Anybody familiar with well-architected framework? Yeah, great. So we know what a well-architected framework is. Now, this is the machine learning lens, and specifically, we are speaking about the security pillar of our well-architected framework. Now, my talk, just like it's not going to be as interesting as the next talk, I'm not going to produce any NFTs. It's going to be about practicalities, about best practices, about how to do the machine learning work, real work, as in how to do the thing, as in, because when you are working machine learning, you hear about lots of theory, but less of work that needs to be done. As you need to do the work at the end of the day, you will need to have those notebooks, running through those notebooks, and then deploying them, worrying about the compute, about the power, about the CPUs, about the memory, about everything, and mainly securing your workloads. So I know Nick went through this slide. As he said, this slide is something that we have to go through and speak about machine learning workloads. But for me, I just want to take you through, for example, some of the use cases, what I've been working with my customers through some of those services. So, for example, one of my customers recently is a healthcare provider, and we are working to use Transcribe Medical, specifically to just translate speech to text, and then from there use Comprehend Medical. Again, we have something here, Comprehend Medical, as you see here. And from Comprehend Medical, we are taking insights about the diagnosis, about the different health indicators from the discussion that they have between the consultant and the patient, and then we are transforming that to a report that is exported to automatically to the healthcare system that they're using. So this is a real case that I'm working on right now using the AI services on the top. The other example I'm working on as well is personalize. Personalize is a service. My customer wanted to personalize news items. It's not personalizing products. So they are providing news items. They are a trading platform, and they want to personalize news items based on the interests of their customers. So they use personalize directly, and they were capable of personalizing those news items to based on their customers, their interests, which pair of those currency commodities kind of interest them, and then expect what they're going to be interested in, or expect, for example, what's going to be as more relevant to them based on their previous interactions with other news items. So you can think about those use cases and look at the top layer there, all implemented using the top layer. And of course, forecast. Forecast is a very popular service, and you use forecast to predict business metrics, business values, any value that you have history of this value produced. You can use forecast to predict in the future. You can get up to 3, 4 months, 5 months, 6 months, 1 year of predictions. We use it with currently one of my customer provides energy, which is very important, very relevant in these days, energy prices prediction. And my customer is predicting this for 6 months and producing reports for our customers and selling these reports, which we call them as they call them as prediction curves. They produce a prediction curve as a product, and they're selling to their customers using forecast. Of course, if you want to produce predictions for 6 months, you need to have history of at least, my advice, at least 5 times the amount of prediction that you want to produce. So this is another application using forecast. So as you see, we have this top layer of those services. All of them are something that you can use straight away. I gave you some examples from customers who are doing it. But at the end of the day, you will need builders, you will need data centers, they will need a platform to work on, and this is what SageMaker is as a platform for data centers and builders to build machine learning workloads and have all of the facilities to do monitoring, to do visualization, to do versioning, all of it done from a single platform. And of course, the bottom layer there is where any kind of machine learning practitioner would want to select their framework of choice. They would want to select their kind of preferred compute, for example, and tailored containers for their machine learning workloads. They can do that by using the different available frameworks and different, as you see on the right, GPUs, Inferentia, Elastic Inference, FPGA. All of that is possible as a compute layer for your models. Obviously, I think you all heard about serverless inferencing, which has been released recently, which is something, I think, very, very interesting that we should all look at. All right, so the normal machine learning life cycle, and there are different theories, different ways how we define how people go about machine learning life cycle. But in AWS, we always try to start and like to start from the business goal. So in the business goal, the important thing in machine learning life cycle is to set objective, to set business metrics when you think about the machine learning problem. So you're defining what business problem this machine learning project is solving. And based on that, you should define the metrics. And why it's important to define the metrics or the business outcomes in a measurable way? It's important because you're going to relate back, as you see the blue arrow, coming to the monitoring phase. After deploying the model at the end, it will be in the monitoring phase. It's always good to monitor your model against the set objectives that you have set when you started the business goal. And then you move after the business goal to the machine learning problem framing. And in the framing phase, you will start identifying which data sources you have, what is the input that we're going to go for this model, and what is our target. We call it target variable. In machine learning, we call it target variable is what I'm going to predict, what I'm going to produce. Or sometimes we call it the label, target variable or the label. This is what you decide here in the machine learning problem frame. It's important in the machine learning problem framing to decide on the performance metrics of your model. Now we moved on from business metrics at the first stage to performance metrics on the second stage, and this is the machine learning problem framing. And you set up as well the error metrics in order to measure, as you need to decide how you're going to measure errors and what's happening with your model. And then we move to the data processing phase. I have very long experience in data processing phase. I've done multiple talks as well about feature engineering, which is part of data preparation. So if you have any questions or you're interested in data processing, feel free, or feature engineering specifically, any technique that you want to know or anything, feel free to reach out to me. Happy to discuss it further. But data processing, as you already know, takes about 60 to 65% of the whole life cycle. And this is something that we need to be aware of, and this is how important data processing is. 65% of the full life cycle is taken by the data processing part. Data processing includes data preparation, includes EDA, which is exploratory data analysis, includes feature engineering with all of its flavors. There are flavors of feature engineering, starting from feature extraction to feature, we call it as feature extraction, and then we have the feature selection, as the feature selection, which is selecting the important features that are important for your model. And you see the iterative model between model development and data processing. This is the iterative part where you start building your model, and then when you start building your model, after that you start training your model, then tuning your model, and after that, once you are happy with it, finishing all the iterations, going to feature engineering again, selecting new feature sets, you get the model that you expect as meeting your metrics that you have set on the first two stages, and then you move to the model deployment. In model development, there are multiple maturity models for companies, how they do model development. As in most startups will start by a data scientist logging to SageMaker and starting building a notebook, and from there deploying their model. This is stage one. I can assure you that there are more advanced stages, more scalable stages, and I can provide guidance on kind of measuring the maturity model and helping you pick the next maturity model for you in the model development phase. When you are doing model development, you will expect to have a CI/CD pipeline, and in machine learning we have something called CT pipeline, as in continuous training. Because in machine learning, it's not about building a model and that's it, deploying it. You will need to think about the need for continuous training for that model to meet the expectations for you. After doing the model development, you will deploy your model. And of course, this is not the end of the story. Once your model is deployed, you will need to monitor your model. Why do I need to monitor my model? Because of problems such as data drift problem, changes in the data that your model is receiving on the inference endpoint, or model drift problem. Model drift problem is another kind of problem, and feel free to speak to me about those things and how to mitigate and how to deal with those problems. I'm happy to discuss it further. So this is the machine learning life cycle that we have. And of course, when you are working on all of that, you will need to ask, am I well architected? Am I following the best practices? Am I following what other companies are doing? And in AWS, we built the well-architected framework. And the well-architected framework is taking experience from the thousands of customers that we are working with, taking experience from them and injecting it into those frameworks. We have a general well-architected framework, but we have a specific, we call it lenses for different types of workloads. And that's why we have a machine learning lens. Now, why well-architected framework is important? Because any technology project or any technology workload is just like a construction project. If you don't have the basis or the structure, the basic structure of the building built correctly, you will struggle to deliver the outcome expected from the structural project. So you need to have the basis available for you before starting the project in order to have the outcomes expected and to achieve those outcomes efficiently and to continuously improve on them. So this is what well-architected framework is for. And as you see, it's divided into 6 pillars. And for example, operational excellence is about introducing processes, introducing procedures, making sure that your workload is performing based on the set objectives or metrics for that workload. Security is job one, always thinking about it first. But in the case of machine learning, security includes model, it includes the data, it includes the hyperparameter, it includes the endpoints. So there are many factors you need to consider once we are discussing machine learning workloads. Reliability is about resilience, is about being fault tolerant, is about making sure that you are providing traceability for your model, explainability for your model. It's all about the reliability of your model. It's always important to design for robust models from step 0 when you are working in machine learning workloads. Performance efficiency is about adapting to the different performance levels that you have. For example, sometimes you would need to provide for thousands of requests, sometimes it's hundreds of thousands of requests, so you need to provide for both. And from performance efficiency as well, it's about identifying any kind of compute instances that are over-provisioned or under-provisioned. So it's about optimization as well. So you need to identify those things and to provide for performance efficiency. And identifying, for example, over-provisioned or under-provisioned instances will help you to meet the cost optimization factor, which is about making sure that you're running what is enough for your workload, not more, not less, while meeting the other requirements. Sustainability has been added as a 6th pillar, and we are working towards producing more kind of guidelines about it. But AWS will help you to meet your carbon footprint requirements. As if all of us are working in different organizations, we are working towards establishing those carbon footprint targets. And once we establish those, we are working towards them. We need help about achieving those targets. And AWS, moving to the cloud, help you to achieve those targets, and you'll be able to know your carbon footprint by the available tools there. So, how does the process relates to all of this? So we have the well-architected machine learning life cycle. In this life cycle, the one that we introduced in the first slide, it is related to all of the pillars, and you interact with all of them actually. But today we are speaking about the security pillar. We're focusing on one of the pillars, which is the security pillar. In general, a machine learning kind of design principle, well-architected design principle, starts first by assigning the correct resources, assigning the correct number of resources, the right skills to the project, alongside accountability and empowerment as well to do the job. Providing protection is important by making sure that you secure all the components of your machine learning workload, and in addition to the resiliency factor, Reusability is always something good to think about. Any code development project, reusability is an important factor to think about. To reproduce your work, your problems, or what's happened in machine learning, it's important to have a way to revert back to previous versions. It's not about having version control. In machine learning, it's important to do a kind of to go to, for example, a point in time kind of release. That's very important, and it's a requirement, by the way, by the regulators. If you're doing any machine learning workloads, it's important to think about going to a point in time about the model that was working at that point in time, about the data that you trained your model on at that point in time. So it's not about the code only, it's about the data as well, about the hyperparameters that you use to train your model at that point in time. So that's why reproducing any stage in your model is important, and to track and for auditability purposes. Optimizing, you need to do the trade-off analysis between the different components in order to meet your outcomes. And reducing cost, of course, is always important. The most important thing I always like about this is automation. When you are working in a single model, 2 models, 3 models, it's easy to manage those models without any automation. But I know customers, an online bank, for example, they have around 200 models that they are managing. And those 200 models obviously cannot be managed without automation. So that's why pipelining is important. So we have pipelines to manage those models. Scripting is available for you as well for those kind of automation tasks. So there are multiple techniques depending on your preference to do automation. And people use different tools to orchestrate the automation processes. Some of them will use Kubeflow, for example. Some of them will be using step functions. Some of them will be using Apache Airflow. So there are different ways. But you have to do automation, and you have to orchestrate your automation in your preferred tool. All is supported by, all of what I mentioned is supported by AWS. And in machine learning workloads, it's not a one and done kind of job. It's always iterative. So continuous improvement is something embedded in the process. You have to think about continuously monitoring your models while they're running and improving them by triggering retraining and probably revisiting your data set sources as well. So those are the principles. As I said at the beginning, we're focusing on security. And in the security, we have a set of best practices. And you can see on the right there, as we have best practices aligned to the 6 phases that we have for the machine learning lifecycle. So we have those 6 phases, and we have 13 kind of general best practices. And under each best practice, there is a couple of points to check. So revisiting again the concept of well-architected. What is well-architected? It's not an audit. It's not an inspection. It's just like something to remember or something to advise you about the best practices that are in the industry. If you are following them, tick, that's done. If you're not following them, you can be enlightened, for example, what can be there for you to work on, or you can say this is out of interest for me, as I'm not interested in this part. Can be, so it's not something as in to say that it's an audit or an inspection. No, this is not the case, or this is not why well-architected framework is there. It's about advising you, enlightening you about the best practices in the industry. And here we have 13 best practices available for you. So I'm going to go through them quickly as with each phase. So with the business goal identification phase on the top there. In this phase, when you start the business goal identification, you need to start planning the technical resources behind that. And first thing is to think about establishing a package mirror for your artifacts that you're going to use for your model. Most of people starting in machine learning will think about using resources directly from the internet. If you want to work on the enterprise level, internet access is not allowed for machine learning workloads. You can access internet while you're working on a sandbox, but you cannot access the internet if you are working inside the machine learning platform. Depends on the use case, but we have to differentiate between a sandbox and a production, not a production, let's say a production level development environment for machine learning workloads should not have internet access. That's why establishing a package mirror is important. And then you need to analyze the packages that you are planning to use. Do they require internet access? Do they require access to outside APIs? So that's something as well for you to think about. And of course, you need to identify the licensing requirements and the privacy requirements for the different components that you're using in your model. Then you move on to the phase of machine learning problem framing. And framing is about restricting access, defining who has access to your model, defining access by business role, and just like defining roles built on business roles is a community practice. And then in this phase as well, you start bootstrapping your instances that you're going to use for your machine learning workload. And bootstrapping means that you need to prepare those notebook instances that you're going to use for your data centers by introducing something what we call life cycle management configuration. And those are configurations where you configure those notebook instances, pre-configure them with all of the restrictions that you want them to be there before deploying them and having them working for your data centers. So after that phase, data processing phase, this is one of the important phases, as we said, and data access is the big problematic kind of issue that we have with machine learning workloads, where you want to give access to data centers, but you don't want to give access to your data. So you want to give access, but you don't want to give access. So this is the dilemma that you have with your data owners. And that's why you need to have, for example, policies, and you need to have encryption in place. You need to have assurances for your data owners to provide the data for you. You might sometimes some data is sensitive by nature. It contains PII data. So as a data scientist or as a data engineer working with data centers, you might consider what we call reducing the data sensitivity. As in, this is something that we do with some of our customers. We are advising to reduce the data sensitivity to make it applicable for machine learning workloads. So you have to do all of that, but you have to establish the data lineage as well. Data lineage is about knowing who has the ability to change your data. Where did the data come from? How the data was collected? All of that should be considered in data science workloads, because the reliability of your data will decide on the performance of your model, and if you will be able to judge the performance of your model. Moving on, after that, we have the model development. Here, there is something important, I find it very important, which is detect transfer learning risk. Transfer learning risk. Anybody knows what transfer learning is? Yes?
So it's the action of taking a model that's already been trained on a data set and effectively be using elements of that in a similar data set.
Yes.
So a popular example is with the MS hands-on data set transfers learning issues often like that.
Yeah, spot on. That's absolutely right. So it's about taking a model that has been trained already. And when we say trained, what is a model? Coming from a mathematical background, a model is matrices, yeah, with some numbers there, and filling the matrix, one matrix, or 3, or 5, or 6 matrices. This is what a model is, actually. So transfer learning is about taking those numbers ready trained for you, taking all of those probabilities ready for you. And then you can run your own training on those models and train this model based on your data. So this is what we call about transfer learning. So thank you for clarifying that. But then there's something about detect transfer learning risk. So there's a risk of taking numbers from a model that was not trained properly with, for example, biased data, with a model that did not consider the correct parameters when it was trained. So it's not always a good practice to take any model that has been trained and transfer that knowledge to you and do your training on top of that. There's a big risk that organizations face if they do that straight away. There is a practice recently that is called ZSL, which we call it zero-shot learning. And zero-shot learning is just about same thing as in transfer learning without even training on your data. We call it zero-shot learning, and we're taking that model and start working on it straight away without training it in our own data. I worked with a legal company, and in the legal company, they wanted to build a model to detect for example, some figures from the documents that they have. So they wanted to identify those figures in a PDF that they have, where they are, and they just found out a general model, and they took zero-shot learning and implemented that model. The accuracy was horrible. So the accuracy was horrible. It was picking revenue as in loss. It was taking profit as in something else. Why? Because they have taken the trained model as is, which was even trained for something else. It was not trained for that purpose and just used it to work on their data. While others, what we work with them on is to work on a transfer learning. After taking the model, train it on your own data, and then deploy your own model and work on it. And that increased the accuracy for that legal company by around 24%. Increasing the accuracy by that figure is really, really huge. So this is the kind of the importance of that step about detecting transfer learning risk. So while building your model, think about encryption all the time. And when you think about encryption, it's not about encrypting data at rest. It's about encrypting data in transit. It's about encrypting data while training. So if you have a cluster of instances where your training job is running, you need to consider encrypting data exchange between the cluster when you are doing parallel training, for example. So all of that is important. We are developing a model. Anybody who doesn't know data poisoning effects, do you know data poisoning effects? Yeah?
So it's quite interesting. You can input an image of a cat in a model and it will detect a cat, but you can change it extremely subtly to look like a cat to a human, but the model might identify it as a dog, and that will poison the data. Or if you want to inject an image like a dog and search a cat, that will also cause that.
Exactly, thank you very much. And the same example that you took applies to normal data as in relational data. If we think about the database, same as in a diagram, you can think about a record, same thing. It's a diagram of values. So taking this, changing it a little bit, tweaking the model will affect the accuracy of your model on that when it's running into production. So you need to be aware of those threats and not only developing a model and testing its accuracy only based on the data that you have. You need to be aware of those and other things as well that are available. Now, after you are happy with your model development, you selected your hyperparameters, and you tested your model multiple times, validated it, evaluated it. You need to think about deploying the model. And now there are new ways and new attacks that happen on models on deployment. A new one, which happened recently, again, I'm speaking from experience with customers, insurance companies. Insurance companies will train models, for example, to give you the insurance value based on a set of values. They will predict what you're going to pay. Imagine that you can call the API for that model as much as you can, and then trying with different values. Would you be able to tweak or break down that model at the end of the day? If you can call the API multiple times, you will be able to know which factors are important. Is it where you live? Is it, for example, where you park your car? Which factor is more important for their model? And then you can break down their model. You'll be able to always get a less insurance value because you know what's important for them and what's not important, because you have a chance to do what we call it repeat attack. We call it machine learning repeat attack. A repeat attack, you'll be calling the model endpoint multiple times, trying multiple values until you break that model and you know what's important or not. This happened to an insurance company that is working in this field, and now they have introduced a throttle on the API using API gateway rather than offering the API, for example, and they have tested for those kind of things. For example, asking for a signature once you do an API call rather than having an open API call for anybody. So those kind of things are new things, and you wouldn't be aware of them, and you need to provide for them. And of course, malicious activities, or what we call it fair usage as well of machine learning, is an important, what we call it now in AWS, we call it responsible AI. It's an important thing to consider. So responsible AI has multiple perspectives, but it's something for you to consider in general in the model deployment phase. And monitoring your model, again, monitoring, same applies what we have discussed about anomalous activity, somebody calling your API multiple times, restricting access to your APIs. How will people within the your AWS account call the API, which is internal users, and how external people will be calling those APIs? So there are different patterns how you introduce them. There is a recommended way for example, external users, of course, to use API gateway, while for internal users, it's always recommended to use, for example, temporary credentials, which you all know how to produce them using IAM to access those. So those are best practices. There's more and more to them, but they will change, because machine learning area is a kind of an evolving area. But this is what we have as an advice for different customers. Now, security in Amazon SageMaker benefits from the bigger AWS ecosystem. I'm not going to go into this slide too much, but we benefit from IAM for defining roles. We benefit from CloudTrail and CloudWatch for logs and for CloudTrail for auditing API calls. We benefit from the security provided by the VPC security, and we're going to touch with this in the next slide. And data protection by using all of the kind of encryption, bringing your own key. There are different kinds of encryption capabilities available in AWS. All is possible to apply in your machine learning workload. And most importantly is the compliance validation. Most of you work in organizations that are regulated, and because they are regulated, for example, in health, we have HIPAA regulation. In other environments where we might have FIPS kind of regulation or different types of regulations. So compliance is an important factor, and AWS tools, there are multiple compliance kind of certificates available for the different products. Now, in common security patterns, I'm gonna go through them quickly. I know we run out of time, we run over, but just like a quick place as for private networking starting. So it's always recommended to have your SageMaker components running with no internet connectivity. That's recommendation 1. Differentiate between a sandbox and a production development environment. And communication should always happen through VPC endpoints. If you're not familiar with what VPC endpoints are, happy to explore that more with you on a one-to-one basis. And of course, you always restrict access to those endpoints by using policies. Based on those VPC endpoints, you can define policies about who and what accessing on those endpoints. Now, once you spin up a domain in SageMaker, this is what will happen. As in, you'll have the domain spinning up for you, what we call it an Amazon SageMaker service account. And in that domain, you will be spinning up your notebooks. Notebooks benefit from the EC2 instances. They are EC2 instances, as you see here. And those EC2 instances will need to communicate with the world. And to communicate with the world, SageMaker will spin up for you an ENI, an Elastic Network Interface in a managed VPC, which will benefit from Internet Gateway, which will secure Internet connectivity to your EC2 instance. But your data lives in S3, and your VPCs are in a separate VPC other than the managed VPC that was spun up for you using SageMaker. And that's why it's important for you not to use this default model. This is the default model. In production workloads, you have to use the more secure model, which is deploying your SageMaker domains using VPC-bound kind of domains. And in VPC-bound domains, as you see here, the communication happens through a SageMaker VPC endpoint here, and then all the communication with your VPC happens through the Elastic Network Interface that is created in your VPC. So just to differentiate between the previous and here, the Elastic Network Interface securing internet connectivity for that notebook was created and managed in a SageMaker managed environment, SageMaker managed VPC. In the second one, your ENI, your Elastic Network Interface, is created in your VPC. Why that's important? You can control the security groups, you can control the ACLs, you can control policies, you can control everything on this ENI and what it can access and what it cannot access. So that's the importance of controlling that part. So it's always recommended to do that. By the way, notebooks can benefit from SSO, what we call it now, identity. There's a new name for SSO. Yeah, AWS SSO. There's a new name. What's the new name for?
AWS IAM Identity Center.
Identity Center?
Yeah, previously SSO.
Yes, yes. That was released last week. So Identity Center, is it?
Yes.
Great. So for you can set up notebooks with Identity Center, the new name for AWS SSO. And once you start your training job, when you spin up your training job, you'll be spinning up instances like this, and those instances will do the same. Each instance will have its own ENI deployed in your VPC, and through that ENI, it will connect to your different resources. For example, this is a training job. You're training this model on multiple instances. This is job 1. And to train the model, you need the data. The data will be brought from S3. and it will be brought internally through the VPC network rather than going to the public internet. So we want to avoid to go to the public internet, hence we want this architecture. So the same applies, this is training. If we, for example, this is how we will do a training job in SageMaker, as in you will define what we call an estimator, and in the estimator, you will define the subnets where you want to have your job being bound, and the security group ID for that job. So this is the estimator. Once you call estimator.fit, it will spin up those instances, and it will create those ENIs for you, which are created in the subnet and security group that you have selected here. So this is how it's done. It's that easy to just a couple of lines just to bind your training job to a subnet and a security group. The same goes for deploying a model and hosting it in production. It's the same thing, absolutely the same thing, except that here you don't have an algorithm. Instead of an algorithm, you have a scoring image, which is the model image that's going to be used to do the inferencing job. So this is the kind of security patterns that we're going to discuss. From authentication and authorization point of view, always speak about or try to implement least privilege access. This is very important. Another important thing, no multi-tenancy. One of the mistakes of data scientists is that they will be sharing notebooks. It's always recommended to have a notebook for each data scientist. This is very important. Some companies will try to get them to share, at least to have, for example, to have to share, but to have different storage, each one. We recommend no multi-tenancy, and we recommend as well breaking workloads into different organizational units. We all know AWS organization. It's always recommended to break workloads into different organizational units based on the workload area. For example, working in for the marketing department, we have some models to have an organization unit for them. Their models should be within their organization unit. If you have another organization unit for other department, so split your models based on their business case and based on their organization unit. It's always good to have a clear separation between the different models. We discussed the temporary credentials for internal usage of your APIs, and we discussed API gateway for external users. So internal users use temporary credentials, and external users use API gateway. For data protection, going quickly through this, encryption, S3 through VPC endpoints, and always as well think about encrypting between containers. So when you're speaking about multi-containers training in the cloud, you have to encrypt the communication. And it's not difficult to set this one. It's just like an option on your training job, say enable encryption using that key, and it will enable that encryption automatically for you. Lifecycle configuration. If you're thinking about building the platform for your data centers to start working, you have to configure lifecycle configuration, which is about defining scripts which are going to be executed when the notebook starts, or when you create a notebook. It will configure the notebook with your, for example, which is your preferred mirror, which your preferred, do you want to enable internet access or no internet access? And of course, one of the important things is to limit root access to the notebook instance. And this is again can be done by just flipping one of the options once you create those notebook instances. So it's important to disable root access to notebook instances. Artifact management, we said as restricting internet access, use the your mirror package. Lifecycle configuration, and use not only a version control system, but you have to revert back in time to a point in time, not for your code only, but for your data, for your hyperparameters, for your metrics that you have produced for your model, to know, for example, what was the accuracy at that time and what's the accuracy with this model. So you have to maintain all of that, and that's why we have model registry. Finally, auditability. This is the last slide, which is about using CloudWatch logs for your notebook instances, and logs for your training jobs, logs for your hosted models. All of that goes to CloudWatch. All the calls to SageMaker should be logged to CloudTrail, and you have to switch on the CloudTrail log for S3 object accessibility. And we all know that S3 is used for saving your models, and S3 is used to where your models will be pulled from S3 and included into an instance to start the training job. That's why once you use S3 for that purposes, you have to switch on version control, and you have to switch on what we call it object lock in S3. As in, there is an option in S3 where you can lock objects. So this is important to set up for your models to control your models and to avoid changing them without knowing. Thank you very much. That's all for my side. I hope you have benefited from those models, and please feel free to discuss with me any of those, or reach out to me to my email or through LinkedIn. I'm available, any of those options. Happy to discuss it further with you. Thank you very much.